So this is your Chem 1 lecture over net ionic equations. So we built up to writing chemical reactions, and then we practiced writing out the phases. So that's figuring out whether things are solid, liquid, gas, or aqueous. Today we're going to talk about how to actually look at the total change in the ions. So sometimes you're interested in exactly what every single element's doing in that reaction, but sometimes you're really a lot more interested in just what's the change, right? So net ionic has to do with the net change in those ions. So what you're going to do is you're going to write out and balance the complete molecular equation as we've been practicing. Then you should be then writing the complete ionic. So that's just showing that everything that is aqueous in water is actually going to dissociate or break apart into its ions. Then you have to cancel out the things that are the same. Then the net ionic is just writing out the things that changed. Type of reactions you're going to see one example of each. A single replacement reaction. You can see a double replacement reaction where a solid product is formed, that's a precipitate. You can see an acid-base reaction where water is going to be formed, or no reaction, those are the best because they're easy, where actually everything ends up being soluble. So you're going to see kind of each of these guys in the examples today. So the first example is going to be a double replacement precipitate. So this process is very similar to what we've been working up to. So we need to write out the entire molecular equation. So we're going to have to start off with our reactants of strontium chloride. So strontium's plus 2, Cl's minus 1. So we're going to end up SrCl2. Figure out that phase notation, so check your solubility rules. Remember, look up chlorine first. Then if you look up strontium, it's going to tell you that it's soluble, so we can write AQ after it, plus we can write out sodium sulfate, so sodium is plus 1, but sulfate's negative 2, so we're going to Ma2SO4. So to look up those solubility rules, look up sulfate, then look up sodium. It's going to tell you it's aqueous, so we're going to write AQ after it, give ourselves an arrow. This is a double replacement reaction. We have two compounds, so strontium and sodium are going to swap places, and we're going to end up with sodium and chlorine together. That's table salts. Look up the solubility, although you probably know table salt definitely does dissolve in water, but if you use your solubility rules, it's also going to tell you that. That's good. And then, let's see, we're going to end up with strontium and sulfate, plus 2 and minus 2. Let's look up the solubility rules. So sulfate is about in the middle. Strontium tells you it's going to be not soluble, so we got to put an S there. So we got to balance this guy out. So let's see. Our chlorines aren't balanced, so I put a 2 in front of my sodium chloride. That's going to balance it. Now the complete ionic equation, that is where anything that is aqueous, we're going to have to show it actually dissolving. So first maybe we want to zone in on what this would actually look like in our beaker. So if we had strontium chloride in a beaker with water, so here's our water, and all these beakers, and I put strontium chloride in there, it's going to actually break apart into strontium ions and chloride ions. Right? They're going to be floating around. They're aqueous, so they're going to be floating around in there. Same thing with the sodium and the sulfate. That says it's aqueous, so I'd have sodium ions and sulfate ions floating around. If I mix those two beakers together, I'm going to end up with strontium sulfate. That's going to be a solid in the bottom of that beaker, that's a precipitate, but we're still going to have sodium ions and chloride ions floating around in there because they're still aqueous. So it kind of gives you an idea of what ions are changing and which ones aren't. So if you look, let's see, our sodium ions are going to, they started as aqueous and they ended as aqueous. And same thing with our chlorine, right? There's an ion there, it's an ion there. Those guys didn't change, but what changed was our strontium ion and our sulfate ions coming together to form a solid. So the net ionic is what is green here, right? That's showing what changed. So the best way to do that without actually sitting here and having to draw beakers is, so the easier way to do this besides showing those beakers is to break apart everything. So anything that's aqueous, we're going to break it apart as opposed to drawing it floating around in a beaker. Let's just draw it in one big line. So for example, strontium chloride, we said it was aqueous. So let's break it apart into its two ions. So we'd have strontium ions that are aqueous and 2 chloride ions that are aqueous, right? This guy's going to break apart into those two. And then we have sodium sulfate, and that guy we also said is aqueous, so it's going to break apart into 2 sodium ions that are aqueous and a sulfate ion that's also aqueous. So notice I'm breaking them apart, I'm writing their charges, right? They've been together, they've exchanged their electrons. And I'm also maintaining the fact that they're aqueous on there. Draw an arrow. I'm going to do the same thing for sodium chloride since we said that's going to be aqueous. So I have 2 Na plus 1 aqueous plus 2 Cl minus 1 aqueous, but I'm not going to break apart strontium sulfate. It's a solid. So now we're going to cancel out anything that's the same on both sides. So that's including how many, what the charge is, what phase it is, whether it's solid or aqueous. So the things that I can cancel out would be chlorine. But chlorine is the same, 2Cl minus 1 aqueous, and I can also cancel out the sodiums. The strontiums changed, it went from aqueous to solid, and same thing with the sulfate, it went from aqueous to solid, so those did not change. Excuse me, those did change. So now we just need to write what's left over at the end. So what's left is I have a strontium ion, that was aqueous, plus a sulfate ion, that was aqueous, came together and formed strontium sulfate, that's a solid. So even though all these ions are going on, the only thing that changed was aqueous strontium and aqueous sulfate came together to form a solid strontium sulfate. This is a double replacement where a solid precipitate was formed. The next one we have is a single replacement reaction. It's with copper and silver nitrate, but the process is identical. So we're going to write out our reactants and our products. So copper is a solid, it's a metal, plus silver nitrate, so silver and nitrate, plus 1 and minus 1. I'm going to look up the solubility rules for that, guys. And nitrate is, anything positive with it is aqueous, so we can write AQ. Give ourselves an arrow. Now this is a single replacement, so we do need to make sure it's going to happen by checking the activity series. Copper's a metal, so it's going to try to replace silver. So let's double check the activity series that copper is more reactive. It's barely, right? It's right on top of silver, but it is. So which means silver is going to be by itself. Metals are solids. And then we're going to have a compound made with copper and nitrate. Anything nitrate is aqueous. But we do need to look up the charge on copper since there's no way to tell. You have to check, just choose the most common. And plus 2 is circled, so it's going to be NO3, 2. Now, the complete ionic, remember that means the things that are aqueous we need to break apart. So copper is solid. Oh, I didn't balance this. Let's go back and balance. Let's see, we need to put a 2 in front of our NO3, so we need to have 2 silvers, and that balances that guy out. So back to my complete ionic. Remember that means anything that's aqueous we do need to break apart. So my 2 AgNO3 does need to break apart, so we're going to end up with 2 Ags that are plus 1 and aqueous, and 2 NO3s that are negative 1 and aqueous, arrow, 2 silvers that are solid, plus a Cu, plus 2 aqueous, and 2 NO3 minus 1 aqueous. Now, we got to go through and figure out what's the same on both sides. Now, I do have copper, but those coppers are different. On the reactant side, it's a solid. On the product side, it's plus 2 and aqueous. So I can't cancel that out. Same thing with the silvers. They're not identical. In this case, I can cancel out my nitrates, but those are the only 2 things that are identical. So which means now we just need to write down what's left. So I've got Cu, that's a solid, plus 2 Ag plus 1s that are aqueous, turning into 2 Ags that are solid, plus a copper plus 2 That's aqueous. There's our net ionic. Now this is a single replacement reaction where we're replacing that solid. Next, I've got an acid-base reaction. So this is going to be a neutralization. So with this one, I've got nitric acid. So nitric acid. So ic is going to turn into 8. So we're going to end up with an H and then nitrate, NO3. Any acid's going to be soluble. And then I have barium hydroxide. Ba is +2, so I'm going to have 2 hydroxides to balance that guy out. Let's check out our phases for barium hydroxide. It's soluble, so we're going to put AQ. So this is a double replacement. So one of the things we're going to get, let's see, H and barium are going to swap. We're going to end up with barium and nitrate. Check out that phase. It's going to be aqueous. Anything that's nitrate is aqueous. And we're going to end up with water. Heads up, guys. Water is not aqueous. It's a liquid. So now let's think about what this is going to look like inside a beaker. So I've got nitric acid, which we said was aqueous. So which means we're going to end up with nitrate ions and NO3 ions floating around. Same thing with barium hydroxide. Both of those guys are aqueous, so we're going to have those ions floating around, but we mix them together and we're going to get water, which is going, these are all in water, right? But this guy's going to stay together. It's not going to break apart, but we are going to get a salt, and the salt here is barium nitrate. So those guys are still going to be floating around as ions. So this one's, you're not going to see a solid sitting at the bottom of the beaker, but we want you guys to be able to recognize that that water is not going to break apart. So now when we go through and we cancel these guys out, we're not going to be able to cancel out that stuff in water. So HNO3 is going to break apart. I forgot to balance this. I got to put a 2 here. I got 2 nitrates and 2 waters. There we go. Now it's balanced. So we're going to end up with 2 hydrogen ions that are aqueous and 2 nitrate ions that are aqueous, plus our barium hydroxide. That guy's going to break apart too, so we're going to end up with barium plus 2 aqueous and 2 hydroxides aqueous. There we go, that's our barium hydroxide. And now barium nitrate, same thing, it's aqueous, so we've got to break this guy apart. But we're not going to break apart our water. It's a liquid. So now it's a matter of canceling out the things that are the same on both sides. So the nitrates are going to cancel out and the bariums cancel out. Write down what's left over. So I've got H, let's see, 2 H's that are +1, aqueous, plus 2 hydroxides that are -1 in aqueous, turning into 2 waters. Now if you look at this, all of these guys have a coefficient of 2, which means you can actually reduce it. So this 2, each 2 can now be erased, and now it's really 1 hydrogen and 1 hydroxide coming together to form 1 water. So this is a neutralization where we're forming water. Remember, water is not aqueous, it's a liquid, so it stays together. And my favorite, because it's the easiest, it's where no reaction actually happens. So let's go through and kind of talk about how you can recognize that and how it works. So we have sodium chloride. That's table salt, guys, so we know it's aqueous, plus ammonium sulfate, so NH4 2SO4, so we do have to look up the solubility rules for that guy. We're going to look up SO4 and ammonium. You're going to get that it's soluble, so we've got an AQ there. Curve results in arrow, double replacement. We've got to swap the Na and the NH4, so we're going to end up with NH4Cl and Na2SO4. So ammonium chloride, you got to look up chlorine. with ammonium is going to be soluble. And then Na2SO4, look up your SO4 with Na, it's also going to be soluble. So what's different about this one is that every single one of our reactants and products are aqueous. So if you think through this next step, if we went through, we would have to break apart each one of these, all of them would cancel out. Because of that, there's actually no net ionic here. Everything's going to cancel out. Now the reaction does happen, but there's no net change in the ions. So sure, the reaction happens, but there is no net ionic that happens. So you've seen one of each type of reaction. If you notice, as I do these, I balance, if I can remember, the first one and then carry down those coefficients. They should work out. And also every time I write either a compound or an ion, I write its phase after it. So there was lots of writing aqueous today. Please remember to do those things as you practice.